Question 5. We have a 3.17 kilogram particle. It's subjected to a net force. It varies with position. The particle starts from rest at x equal to 0. What is its speed at position x equal to 5, x equal to 10, and x equal to 15? All right, so it's similar to the one that we had previously in one of the, I think it was question 2. Yeah, question 2. But this one's a little bit different. It wants to know the speed. Okay, so we have, let's see, a 3.17 kilogram particle. There's a force involved, which means there'll be work that's underneath the curve, which means we'll have work is equal then to F. Well, if we're doing the integration, it would be F dx from x initial up to x final. But we know that to be just the area underneath the curve. We also know that the work can be equal to the change in the kinetic energy, if that's the only thing that changed, and it did not mention any type of spring or gravity change. This is only in the x direction, so there's no y. So we know that work done will have to be equal to the change in kinetic energy. So first we need to figure out the work. Okay, and it's the same as the previous problem in question 2. For A, the work done would just be the area underneath the curve, which would be 1/2 5 times 3, so this would be 7.5 joules of work. Okay, so that's our work. And that has to be equal to the change in kinetic energy. Okay, so change in kinetic energy is 1/2 mv squared, and this is final minus initial. Okay, final minus initial. Well, initially it says that it was particle starts from rest at x equal to 0. So initially there was no motion. That goes to 0. So we'll have 7.5 is equal to 1/2 the mass. That was 3.17 times the final velocity squared. So that's what we're solving for, is final velocity here. So I'm going to take half. Well, I'm going to take 7.5. I'm going to multiply it by 2 to get rid of the half, and then I'm going to divide it by the 3.17. And that'll get me 4.73. Now let me just take a square root of that answer, and I get that VF is equal to 2.175, so it's going to round to 2.18 meters per second. Okay. So now we have that for our final velocity on part A. Part B will work the exact same way. We need to figure out how much work was done. Well, that's this box. So that's 5 to 10. So this is 5 times 3. So the area inside of that box is 15. 15 will be equal to the 1/2 mv squared minus the 1/2 mv squared initial. This time there is an initial. It is initially going 2.18. We're looking for the final. So it'll be 1/2 m, 3.17, times v final, which we don't know yet, v final squared, minus 1/2 m, 3.17, times vi squared. I'm running out of paper over here. Vi squared is going to be 2.18 squared. All right, that gets tagged onto the back of that. 2.18 from over here, 2.18 squared. Okay, so this is just a number here. We'll go ahead and we'll figure that out. We'll have 0.5 times 3.17 times 2.18 squared, and it gives us a value of 7.53. So we're going to have 15 minus 7.53 is equal to 1/2 3.17 VF squared. Plus. My mistake, plus, because this is already a minus. It's a minus this, so we'll plus it to the other side, so we'll have an addition there. All right, so we'll take that, we'll plus 15 to it, and then I'm going to take and I'm going to multiply it by 2 to get rid of the half, and then I'm going to divide by the 3.17 to get rid of that, and then finally I'll take a square root to get rid of that square. And if we do all that out, we get a value of 3.77 meters per second. So there is some math involved in there. have any questions on this, just come and see me on the math terms. Otherwise, I'm hoping that you can follow it by now in this part of the course, that we're adding these two numbers. To solve out, I multiply by 2 and I divide and I take a square root. I'm combining all of those into one step. And finally, the last one, C. Same formula, same question. Now, at 15 meters, we have to add this in as well, right? So at 15 meters, how much do we have going on? So at 15, we'll have an extra 7.5 coming in from that. Equals to, there is actually another way of doing this. I should show you the other way as well. So right here, I'm breaking it up into sections, and I'm saying that we had an initial velocity here, and we added it in to this one here. That's how we did this, right? Just to say it's initial. There is another way of doing it, and that's to do from x equal to 0 to figure out what the speed would be here. So to do that, we assume that x is equal to 0, and at 15 meters, we're all the way over here, which means the area underneath this curve would be the entire thing. So 7.5, 7.5, and 15 make 30. So let's see what that would look like, actually. If I put the work as 30, then I would set it up to the exact same thing, 1/2 mv final squared minus 1/2 mv initial squared. But because I took in the entire work, it starts at 0, so I can get rid of that. And it just adds that little cancellation. If you did it this way, you'd have 1/2 of 3.77 squared, and then you would add it to the other side. It's the same principle, right? And you add it over to the other side. So in here, we've taken care of that one little extra step of adding it over by starting at the 0 location. Anyway, continuing on, we'd have 30 is equal to 1/2, and the mass on this is 3.17, and we're looking for the final velocity squared. So our steps again, 30 multiplied by 2 and divided by 3.17, and then finally take a square root of your answer, and you will get that VF over here is equal to 4.35 meters per second. So there's two different ways of doing it, however you'd like to work through the problem, but each of these can be done its own way depending on what the question is asking. This one, it just wanted to know what the speed was at these points, so it works out just fine.